Hello Math 110 students, welcome back. Let's continue with lesson 2.3 today. 2.3, we're going to go back through and kind of take a look at a few things. First of all, we would like to recognize quantities that can be added. So many times in this course we're going to be picking up things and seeing if we can add them. Do we need to do a change in dimensions? Can they naturally be added? Can we simplify math operations? And that's what we're going to talk about here. So quantities can only be added if they are like quantities. Like quantities can be the same dollar amount using the same currency, the same lengths, the same weight methods. For example, you can easily add $10 and $8, but you can't add $10 and 8 bran muffins, right? I've got $10 and 8 bran muffins. They don't go together. The easiest way to decide if quantities are like is to cover up the number part. If what's left over is identical, the units, the quantities are like. So if there are any differences, then the quantities are not like and cannot be added in general. So 202 pounds plus 15 pounds, if we cover up those numerics, I've got the pounds and the pounds, so I'm good. Just add up, and we get 217 pounds. 202 pounds plus 15 ounces. Now I can say 202 pounds, 15 ounces, but I can't really add these things. I need to either convert the pounds to ounces or ounces to pounds, and then I can go. 12y and 22y. If I cover up these numbers, these are the very same. Y and y. These are either the same length, the same mass, the same time, but they're the same number. Okay, so I can just go ahead and do this, add these numbers. I got 12 of them and 22 of them, so now I've got 34 of them. 34 times the y number. So if y was 2, this would be 34 times 2, and that would be your 68. So in this case, they're asking me if I can add 12y plus 22y squared. Well, y is 2, this one is 2, but here I've got 2 times 2, so I've got 4, and I can't directly add those things. So I just have to leave it alone until I find out what the y is, do this small calculation here, square it, order of operations, square it first, and then multiply times 22 and combine those. So in some cases, quantities that aren't like can be changed into like quantities by changing units. So I can do 4 pounds plus 3 ounces. Well, there's 16 ounces per pound, so I can do the 4 times 16, change that over to ounces, and now I've got everything in ounces, and that's 67 ounces. Okay, and it'll let you know 4 pounds is 4 times 16 is 64 ounces. Here I've got $3.50 that I want to add together. I can do the $3 first, and then the 50 cent, and that gives me the $3.50. So I do 1, change that over, and then I've got it. So that's the half from there. If I could do this as, well, $1 is 100 cents. That's 100 pennies. So $3 would be 300 cents, and now I've got my 50 cents, and they're all into that same units, the pennies, and then I can add them to 350 cents. So we know that integer exponents represent repeat multiplications. For example, if I write 5 to the 4th, that means I want to do the operation 5 times 5 times 5 times 5. That number itself, multiply by itself 4 times. 5 times 5 times 5 times 5. So sometimes I just don't know. You remember the variables. I don't know what this number is yet. Sometime in the future, somebody's going to tell me what x is, or I may be able to calculate that value. But this means x times x, and that's x squared. I want to write that as a shorthand instead of carrying this around all the time. So I can do multiplication. Now before I couldn't add these things, but multiplication, let's see what this thing is. It's 4 times y squared times 2 times y. And 2 times y is the same thing as y times 2. 2 times 3, 3 times 2 are both 6. And in general, multiplication commutes. That's called the commutative property. So I'm going to swap these things. So I've got this 4y squared times y. Well, that's y times another y. So I'm just going to add these exponents. This is understood 1. 2, I got 1 here, I just add them up and that's 3. So then I got the 4 times 2 is my 8y cubed, so this all simplifies down. About 4 inches by 2 inches. Well, that's 4 times 2 is 8, and I represent an inch times an inch is inch squared. And when I multiply units at like an inch or length or something like that, whatever that unit is, if I'm multiplying it together by itself, I get squared units. Foot squared, inches squared, yard squared. This square tells me that I'm talking about an area measurement. I mean, I'll look at it, and if I see square inches, I'm saying, well, that's an area. Okay. 6 meters squared times 10 meters, that's 60. 6 times 10 is 60, but I still have to keep up with this. Meters squared times the meter, that's m cubed 2, and 1 is the 3. Now, is that a length? No, that would be just 60 meters. Is it an area? No, that would be 60 meters squared. This is basically 6 meters squared in area times something height. And that's basically a cubic measurement. This is 60 meters cubed is times itself 3 times. So that's a volume measurement. So typically we're going to write procedure as a formula, and we're going to call it a procedure because it's basically a procedure to calculate. If I'm driving, so let's go through this. One of the most common and important uses of variables in math is writing formulas to represent mathematical procedures. For example, in order to find your average speed over a trip, you would divide the distance you went by the amount of time you traveled. This is exactly why a common measure of speed is miles per hour. That per indicates division. I divided miles by hours, miles per hour. It's a distance divided by time. Instead of writing that procedure out in words, I could give you, here's the formula for it, and it says take your distance, the speed s is equal to, calculated by, take the distance, whatever distance you've traveled, and divide it by the time it took you to travel that distance. So here's some prep skills questions that I want you to go over. Take a few minutes. We'll go over, I'll do a sample of 1 or 2. 132 yards and 40 yards, can I add those things? Yep. Can I simplify this expression? I can't add them. I've got a cube and a t, they're not the same, so I have to leave them alone. But in this case I can. 18 plus 10, 28, y squared. If I change my units, then I can add these. 1 foot is 12 inches, 12 yards, 16 seconds. I have no conversion between seconds. This is a length and this is a time measurement, so we better keep those apart. 10 decades and 5 years. Well, I know a decade is 5 years, so if I know a decade is 10 years, so if I keep that, 10 decades would be 100 years, plus 5 years, where it's 105 years. And then I could convert 5 years to 1/2 of a decade, 0.5 decade, and then do the 10.5. Multiplication is okay. Y times y is y squared. 4 times 6 is 24. So these things we can do. That we can do. Kilometer squared is an area measurement. Minus 3x cubed. And then 8 times 12 yard cubes, that's a volume measurement. So here's some things that Tony Wagner, he was an educational consultant, he kind of come up with, and it was like, let me pull this down here. It was Tony outlined 7 survival skills that students have to master to reach their academic potential. Define what each of these skills mean to you. Critical thinking and problem solving. What does that mean? Clear, reasoned thought and evaluation to sort information and solve problems. Collaboration across networks and leading by influence. Leading by working with people and collaborating outside your usual group. This may be across, so you may have to work as an engineer. You may have one team that has to work across the United States, across the oceans, with another team and work together. So agility and adaptability, thinking quickly, adjusting when your job or situation changes. Adapt, be agile, be quick on it. And then finally, initiative and entrepreneurialism. Being self-directed, here's your initiative. I'm going to take the initiative. I'm going to go do something that needs to be done. And then I'm going to try to come up with new ideas or approaches and following through. That's the entrepreneurialism and initiative to go get things done. Assessing and analyzing information. Finding the information, processing it, and evaluating it to decide whether and how it might be useful. Throughout this course, we're going to be pulling down data, maybe simplifying it using some statistics that would be simplifying and then evaluating what that means. Effective written and oral communications. It's a true skill, and you should always strive to be better at writing and speaking clearly. Curiosity and imagination, wanting to know more, coming up with new ways to do things or new ways to think about something. Curiosity and imagination is going to carry us forward out throughout the next 100 years. So here was this quote. Today knowledge is ubiquitous, meaning everywhere. Constantly changing, growing exponentially. Today knowledge is free. YouTube has a ton of resources. It's like air, it's like water, it's becoming a commodity. There's no competitive advantage today in knowing more than the next person next to you. The world doesn't care what you know. What the world cares about is what you can do with what you know. You need to understand the basics, be able to pull down other information, but put that together into something useful. So at this point in the course, you should be pretty comfortable multiplying units of length to find the correct units for area and volume calculations. That's what we talked about before, the square units and the cubic units. So perform each multiplication for parts A and B and include units. What would this be? 2 feet by 3 feet, so it would be the 6, but then I would have the feet times feet is the feet squared, so that's an area measurement. I consider something like a box or just a rectangle, not a box, that would be kind of a volume, but a flat piece of paper, 2 feet by 3 feet, it would cover 6 square feet. 6 feet squared by 5 feet, this would be, here's that carpet that was 6 feet squared, and now I did some sides on it, the box again, and that's the 30 cubic feet. So that's a volume measure. That's how many. So if you had something that was 1 foot cube, 1 foot by 1 foot square, 1 foot high, I could put 30 of those in that box. Here's just simple multiplication. 2x times 3x, 6x squared. 6x squared times 5x, that's the 30, and multiplication is easy. I just add up the exponents. 2 of these, 1 of these, that gives me the x cubed. So when reviewing addition of similar quantities in lesson 1-2, we saw that we can add the expression 8x and 5x to get 13x. So 8x plus 5x and 13x would give you the same output, the same value, no matter which one input you choose. If x was 1, I'd get 8 plus 5 is 13 times 1. If it was 2, I'd have the 16 plus the 10, and the 13 times 2 would be the same 26 value. So that's kind of the same things are equivalent. I get the equivalent values, but it's simpler to write this around. Just here's 13 times this instead of 8x plus 5x. So when working with expressions, equations, and formulas, it's often useful. It's always useful to simplify expressions. Sometimes it's worthwhile to work backwards, but most of the time we're going to simplify. This involves replacing an expression with a simpler but equivalent one. As we saw in the previous paragraph, adding, subtracting like terms is one way to simplify. So use the formula P is equal to A plus B plus C to find the perimeter of a triangle. So this is saying I've got a triangle with 3 sides. The perimeter is just add up those 3 sides. So the length here of each side is measured in inches. First, write the formula, then substitute the expression for each side of the triangle into the formula and simplify the results. So here's A. They're going to start out with this side being A, and apparently this is their B and this is their C. The way they've listed it out, we could have done other ways. But here's the fundamental. If I want to find the perimeter, I want to add up these links around here. So it's add up the first plus the second plus the third, 5x inches plus 12x inches plus 13 inches. So here they said the length of each side is measured in inches is where we got this. This should have been like labeled inches. Okay. So if we add them up, 13 and the 12 is the 25 plus the 30. But what units? This x in inches. Okay. So that's simple. So all we have to do is do it around. So this is basically like if we were dealing with models, and I'm going to hold that and I want to scale this thing in and out. So I want to make a bigger triangle and I want the x to be 2. So each one of these is going to be now 10, 24, 26. It would be the same thing as saying the 30 times 2 is 60. Or I could say 3, 15, 36, 39, and then add those up. So repeat with 10, but this time use the formula A is equal to 1/2 the base times the height to find the area of the triangle. In this case, B represents the length of the triangle's base. This is where it sits on, and then the height is how high it goes up. So in this case, I would write area is 1/2 base times, that's the area inside. That's like if I colored this stuff up. 1/2, the base is 12x inches, the height is 5x inches, and now I want to simplify. Well, I'm going to divide out one of these. So the 12, I'm going to divide by 2, that gives me 6. 6 times 5 is 30. X times x is x squared. Inches times inches is inches squared. So if this was 1, it would be just 30 square inches. If it was 2, x is 2. 2 squared, 2 times 2 is 4 times 3 is 120 square inches. So here is the very same thing. So now we simplify, and now they say do the calculation for x equal to 4. We've scaled this thing out. Everything is multiplied out by 4, and do the calculations. Here the perimeter would be 120 inches. Here the area would be 480 inches squared, or square inches. Okay. So I hope that helps. I hope you found it informative. See you next time. Have a good day.